Hello Math140 students, this is your instructor Cindy Enrique, and we're going to continue with chapter 10, and we're going to pick up on page 11, which talks about section 10.4, which is all about graphing the quadratic functions. So here the graph of the quadratic function is a parabola. So we talked about this before, but we're going to revisit this section. So we know, depending on the leading coefficient, whether or not it's going to be opening upwards or opening downwards. See, we know that if it's a positive, oops, let me rewrite that here. If we have a positive parabola, then it looks like it's happy because it's going to be smiling at you. Versus if we have a negative parabola, it looks like it's sad because it looks like it's frowning at you. So we have a happy positive parabola and we have a sad negative parabola. And the vertex is either the highest or the lowest point on the curve. And we have our axis of symmetry. And so that's just quite some review. But now it says the axis of symmetry and the vertex of the parabola written in vertex form can be written like this, where it's a parentheses x minus h squared plus k, where the vertex is going to be h comma k. So again, we've talked about parabolas before, so this should be somewhat of a review. So please notice that our parabolas, our h value here, if it's a negative, it's positive. So the h value is always going to be the opposite sign, versus my k value is going to be exactly the sign that it is my original formula. So here we go. It says, label the coordinates of the vertex and write the equation of the axis of symmetry. So noticing this formula, I can see where is going to be my h value. So I know that I'm going to have my vertex where I have my h and my k value. So here my h value, it's a negative 3. So here I'm going to have a positive 3. And my k value is there. It's listed as a positive 2. So it stays as a positive 2. So my vertex ends up becoming 3, 2. So I know I've labeled the vertex. Now the other thing it wants me to label is the axis of symmetry. So the axis of symmetry, I have it as x equals to whatever that h value is. So that h value is positive 3. So I'm going to say that x is equal to a positive 3. Okay, so we're just going to keep doing this. So just making sure that we understand how to identify the vertex and the axis of symmetry. So my vertex for number 2, I have my h value and I also have my k value. So I'm going to have my vertex as my h comma k. So the h value is a positive 2. And my k value is going to be a positive 3. So then I'm going to have my axis of symmetry. And that's going to be x is equal to whatever my h value is, which is a positive 2. So I have my vertex and I have my axis of symmetry. For number 3, it's the same process. So I'm going to go ahead and have my vertex. I'm going to have my h value and I'm going to have my k value. So here my h value is going to be negative 1 and my k is going to be a negative 3. So then that means my axis of symmetry, I'm going to have it as x is equal to that h value, which is a negative 1. Okay, so now I'm going to go on to number 4. So I'm going to have my h value, and I'm also going to have my k value. So I have my h value as a negative 3, and I have my k value as a negative 1. So therefore my axis of symmetry is going to be x is equal to a negative 3. And for number 5, it's the same process. So I know I'm going to have my vertex as an ordered pair where I have my h value, which is a negative 3, and I have my k value as a positive 3. So then my axis of symmetry is going to be x is equal to a negative 3. So for number 6, it is hopefully getting boring now because you're just like, oh yeah, I know exactly what I'm doing. I can do this with, within just seconds, where I have my h value, which is negative 3, and I'm going to have my k value as a negative 1. So then my axis of symmetry would be x is equal to a negative 3 as my final answer. Okay. So now it wants me to go ahead and graph the functions. So if I want to graph the functions, the best thing to do is really to, hold on there a second. So I'm going to go ahead and find some values to plug in to help myself out. So I have my x and y values that I can use. So I think that 0 is always a good value to plug into my equation. So let's see if I can get that calculator app back up. So here is my calculator. So I'm going to go ahead and plug in some values. So I have 3 times my 0 squared. And when I do that, my y value is going to be 0. So 0, 0 is a good answer to have. So maybe I want to see what happens when I plug in a 2. So I'm going to have 3 times 2 squared. Now I'm going to get a positive 12. So that's very, very high. So let's see what happens when I plug in a negative 1. So I'm going to have 3 times my negative 1 squared. And let's see what I get. I get a positive 3. So that helps. So let's see what happens with a positive 1. So 3 times 1 squared, and I get positive 3 as well. And why not just check to see what happens when you get a positive 2? So I'm going to have 3 times positive 2 squared, and my value there is a positive 12 as well. So now I have some values that I can plug in. So I have 0, 0. I have 2, 12, which is very high. I have negative 1, positive 3. I have positive 1, positive 3. And I also have a, oops, and that was a negative 2. Negative 2, positive 12. So that's going to be my answer for number 1. Now for number 2 is going to be very, very similar. So I'm going to plug in some values for number 2. So I don't know, let's try 0. Well, 0 squared times anything is just 0. If I were to plug in a 1, and if you need to, you can plug it into your calculator to see what you're going to get. So here I would have a negative, and I have my 1 half times my 1 squared. Now I'm going to get that as a negative 1 half. So, okay, so I have a negative 1 half. So a negative 1 half. That's also the same as a negative 0.5. So how about what happens when I plug in a negative 1? So I'm going to use this exact same equation, except now I'm going to plug in a negative 1. And that's squared. So when I press enter, I get a -1/2 as well. All right, so let's see what happens when we plug in 2 and -2. Well, if I were to plug in my negative, oops, one half, and now I'm plugging in my 2, and I am squaring it, I get a -2. So let's see what happens when I plug in a -2. I get -2 back. So now I have some values to plug in. So I have a 0, 0. I have a 1, -1/2. I also have a -1, -0.5. A 2, -2. As well as a -2, -2. So now I know what this graph more or less is going to look like. Okay. So just plugging in some values. 0 is always a good one if you have it. So now we can go on to example number 3. It says write the coordinates of the vertex and determine if the vertex is a maximum or a minimum point. So if I have a happy parabola, then this point would be a minimum for my vertex. Now, if I were to have a negative parabola, then that point would be a maximum point for the vertex. So it just depends on whether or not I have a positive or a negative parabola. And that's always going to be with the a value, the number out in front. So here is my a value. So here a is equal to 4. Let me rewrite that. I have a is equal to 4, which is positive. Which means I have a positive happy parabola. That means that my vertex is going to be a minimum point. And it also wants me to find the coordinates of the vertex. So the vertex is going to be, remember, the vertex, the h and my k value are here. So here's my h, here's my k. So I'm going to have a positive 6 and a positive 9 for my vertex. Okay, so now I'm going to go on to the next thing. So I have my vertex that I'm going to figure out. So that's going to be a positive 2 and a positive 5. The a coordinate here is negative. So I have that my a is equal to a negative. So that means I'm going to have a maximum point. Okay, so we've written the coordinates of the vertex and determined if the vertex is a maximum or a minimum point. And we're going to do the exact same thing for number 3 and number 4. So for number 3, it's easy to tell what the a value is going to be. So a is equal to 1/2, which is positive. If we have a happy positive parabola, that tells me that my vertex is going to be a minimum point. And here I definitely have my vertex, the h value as -8, but what's that k value? Well, that k value, without changing the value of this equation, you can always add or subtract 0. So that k value would be a 0 there, okay? And for this problem here, you're going to have to maybe perhaps do a, use that formula. So to get the x coordinate of the vertex, you use that -b/2a. So here, my a is equal to a -6, and my b is equal to 0, and my c is equal to 21/4. So I'm going to have negative b value over 2 times my a. So in this particular case, my b is equal to 0, and my a is equal to a -6. But 0 divided by anything is just going to give me a 0. So I know that for my vertex, the x coordinate is 0. So now I just have to figure out what my y value is going to be. So I'm going to get that by plugging it into my original equation. So remember, I have that y is equal to a -6x squared plus 21/4. So -6 plus my 21/4. And that value that I'm plugging in is 0. So 0 times anything is just 0. That go ahead and just cancels out. So I'm left with that 21/4. So I'm going to have my 21/4 as the y coordinate of the vertex. And since my a value here is negative, then I know I have a negative parabola. So I know my vertex is going to be a maximum point. Okay. Now it says a quadratic equation can be written in vertex form using completing the square. So now we're going to do this by completing the square. So for part A, it says write the function in the form f of x is equal to a x minus h squared plus k. Okay, so I know that I have y. I have that y is equal to x squared plus 8x plus 13. So my b value is 8. My b divided by 2, so 8 divided by 2 is 4. And if I were to get that value and square it, 4 squared is a positive 16. So hopefully you remember our formula. We are going to have x, or actually, what I really want to do is kind of write out my general formula. Before we used to have 0, but now we don't have the 0. So it's going to slightly change because I have y instead of my 0. So my general equation with y is going to be y is equal to x plus my b divided by 2 squared plus c minus my b divided by 2 squared. Okay, that's because I don't have 0 anymore, so I just have to be a bit more careful. So I have y is equal to x plus, well, that b divided by 2 value is 4. I square it. My c value is still a 13. And now that b divided by 2 value, I'm subtracting it, and it's a 16. So now I have that y is equal to x plus 4 squared. And I also have a 13 minus 16, which is a negative 3. And to make sure I rewrite it in function notation, I have that f of x is equal to my x plus 4 squared minus 3. So that is going to be my answer for part A. it is now rewritten in my vertex form. So for part B, it's specifically asking me to find the vertex. So I can go ahead and do that. And I'm going to have a -4 and a -3. So that's my h and my k value. I do that just by looking at the equation above. Then I have my axis of symmetry. That's going to be x equal to whatever that h value is. That's going to be a -4. And it also wants to know the minimum function value. So the minimum function value, what that is, all it is the y coordinate of the vertex. So if I have the vertex as a -4, -3, then I know that that's going to be my minimum function value. So I can say that the minimum function value is -3. Okay. For the next example, we have this. So it says to write the function in this form. So, okay, I can do that. So originally I have that my f of x is equal to a -2 x squared plus 12x minus 16. So I'm going to go ahead and factor out a -2 from here. So I have an x squared minus 6x plus 8. Okay. Now I can tell you that my b value is going to be a -6. My b divided by 2 is going to be a, so -6 divided by 2 is a -3. And I have my b divided by 2 squared, which is going to be a +9. So now I have my formula. So I'm going to have y is equal to, and I still have that -2 out in front. I'm going to deal with that later. So I'm going to have x plus my b divided by 2 squared plus 8 minus my b divided by 2 squared. So I'm going to kind of deal with that inside first. So I still have that -2 that I'm going to deal with later. So on the inside here, that b divided by 2 value was a -3. And so when I squared that, I got a +9. And I'm subtracting it. Okay. So that is what I have so far. So when I simplify this a little bit further, I still have that -2 hanging out on the outside, and I have my x minus 3 squared, and a +8 minus 9 gives me a -1. And since I factor out that -2, what I can do is actually distribute that. Maybe I'll use a different color. Maybe I'll use this color. So I'm going to distribute that inside. So I'm going to have a -2 x minus 3 squared plus 2. So all of those steps lead me to the function in that vertex form. So now I can say for part A And I'm going to change that y back to f of x. So f of x is equal to a negative 2 x minus 3 squared plus 2. So that is my part A. Now for part B, it says to identify the vertex. So the vertex here is going to be a positive 3, positive 2. Well, it also tells me to give me the axis of symmetry. So the axis of symmetry would be that x is equal to a positive 3. The next thing they ask me for is the maximum function value. Remember, that's just the y-coordinate of the vertex. So the y-coordinate of the vertex, or k if you want to call it, is 2. Okay. Now it wants me to find the x and the y-intercepts. So, okay, we can do that. So remember that my original equation is f of x is equal to a negative 2 x squared plus 12x minus 16. So if I'm trying to find the y-intercept, I let x equal to 0. So I have y is equal to a negative 2 squared plus 12 minus 16. And I'm plugging in a 0. And 0 times anything just cancels out, so I'm left with y is equal to a negative 16. So my y-intercept, don't forget to write it as an ordered pair, is 0, negative 16. And this is for part C. Okay. So they found the y-intercept. Now it also wants me to find the x-intercept. Okay, so find x-intercept. That means that we let our y value equal to 0. So for this one, it might be easier to use the factored form instead of the one that's not. So I'm going to have that y is equal to a negative 2 x minus 3 squared plus 2. So I'm going to plug in a 0 into my y so I can solve for x. So the first thing I'm going to do is subtract 2 from both sides. So that way I can have a negative 2 is equal to negative 2 x minus 3 squared. Since that negative 2 is being multiplied, that means the opposite of multiplication, I can divide it. So negative 2 divided by negative 2 is a positive 1. And now I have my x minus 3 squared. Well, remember the square root principle is that whenever I have that square, I can square root both sides to get rid of it as long as I don't forget the plus or minus. So I have plus or minus the square root of 1 is equal to x minus 3. And of course, if I add 3 to both sides, I would have 3 plus or minus the square root of 1 is equal to x. So 3 plus or minus 1 is equal to x. So 3 plus 1 is equal to x. So that gives me 4 is equal to x. So therefore, my x-intercept would be 4, 0. The next one that I would have is 3 minus 1 is equal to x. So first equation, second equation. So 3 minus 1 is 2. So my other x-intercept would give me a 2, my 0. Okay. And again, that's all of my part C. Now for part D, it says to sketch the graph of the function. So I have all of my important information. So I have my vertex, and my vertex is at positive 3, positive 2. So 3, 2. So 3, 2 is there. And I also have my y-intercept, which is at 0, negative 16. So that's way down there. I'm not even going to write it. And I also have my x-intercepts at 4, 0, and 2, 0. So more or less, the shape of this graph is going to look like this. It doesn't have to be perfect. It doesn't say graph this parabola perfectly. It specifically says sketch. So it doesn't have to be perfect, but at least has to be in the ballpark. So that is how I sketch the graph of the function. Okay, so now we have some practice problems. So this is where you guys are going to go ahead and press pause, and you guys are going to try to do these problems. So go ahead and press pause. So hopefully you've had enough time to go over this practice problem. So for here, my function is g of x, and what I did first is I wrote the equation as a y equals instead of the g equals to help myself out. Then I factored out the -1 because you always want that leading coefficient to be 1 when you're completing the square. I identified my b divided by 2, and my b divided by 2 squared. And then I wrote out my general formula, and I plugged in the values accordingly. And then I distributed that -1 since that was the GCF. And then I rewrote it in my g of x notation. I found my vertex, my axis of symmetry, and remember the function value is just the y coordinate of the vertex. And then I found my x and y intercept. So for the y-intercept, I let x equal to 0, so I got 0, -5. For the x-intercept, I let y equal to 0, and I got two answers. I got 5, 0, and 1, 0 as the x-intercept. Remember, they must be written as ordered pairs. So then I just plotted those points. So I plotted my vertex, I plotted my x-intercepts, and I plotted my y-intercept. And that is the sketch of the graph. Okay. Now for the next one, it says, hey, we have this vertex formula. So again, to get the x-coordinate of the vertex, we're going to use that -b over 2a. Then whatever value we get, we're going to plug that back in to get our y value of the vertex. So here we have our function h of x. So it says use the vertex formula to find the coordinate of the vertex. So here I'm going to find, so let's say that the vertex is going to be the ordered pair h, comma k. So to find h, we use the formula -b over 2a. So now we have to identify our b and our a values. So here my a value is 1, my b value is -2, and my c value is -5. So my b value is going to be a -2, and my a value is a +1. So what I end up having is a fraction where I have a -2, and my denominator of a +2, so that's going to give me a +1. So now I know that h is equal to 1. So for my vertex, I have 1. That is my h value. Now to find the k value, I plug it back into my original. So my original equation, I have that y is equal to my x squared minus 2x plus 5. So that h value that I'm plugging in is going to be my 1. So I'm going to get, and I'm going to plug this into my calculator, 1 squared minus 2 times 1 plus my 5, and I get a +4. So now I have my vertex as 1, 4. Perfect. So 1, 4 is going to be my vertex. And I already know this is going to be a happy or positive parabola because that a value is a positive 1, okay? Now to find my x and y intercepts. So to find my y-intercept, I let my x value equal to 0. So remember, in my original equation, I have y is equal to x squared minus 2x plus 5. So that x value that I'm plugging in is a 0. So I have that y is equal to a positive 5. So now I can say that my y-intercept is 0, comma 5. Now I'm going to find my x-intercept. So I'm going to go ahead and let my y value equal to 0. So here, I'm going to go ahead and plug it in. So I'm going to have my 0 is equal to my x squared minus 2x plus 5. Notice that here it does not factor at all. So I can go ahead and plug it into my vertex formula. So for my vertex formula, I'm going to have that 0 is equal to my something squared plus something, where this is x plus my h plus my k. And I already have my h and k value. So this is going to be x plus 1 squared plus 4. And actually, remember, inside the parentheses, don't forget it's always going to be the opposite sign, so it should really be a negative 1 that I plug in. Since my h value is a positive 1, when I plug it into my equation, it's going to be a negative 1, okay? So then from here, I am going to subtract 4 on both sides. Let me write that a little bit nicer. So now I'm going to have a negative 4 is equal to an x minus 1 squared. So to undo that square, I'm going to square root both sides. But be careful, now I'm going to have a plus or minus the square root of negative 4 is equal to x minus 1. I can stop here because this is a square root with a negative on the inside of a square root. When that happens, we say it's a non-real solution. So it's safe to say that there is no x-intercept. So x-intercept D and E does not exist. So the x-intercepts actually don't exist. So let's see what we're talking about here. So I already have my vertex. That vertex was a 1, 4. And I have my y-intercept at 0, 5. So my y-intercept's at 0, 5. So more or less, my parabola looks like this. So notice how this parabola does not have any x-intercept. It does not hit the x-axis anywhere, okay? So that is why this particular graph does not have any x-intercepts. They do not exist. All right. Now we have another example, just to make sure that we have it. So we're going to use the vertex formula to find the vertex. So again, I have my y is equal to x squared plus 4x plus 6. So to find h, we're going to use that formula, negative b over 2a. So let's figure out what those values are. So a we have 1, b we have 4, and c we have a 6. So I'm going to plug this in. So my fraction now becomes a negative 4 over 2, and that's going to give me a negative 2. So for my vertex, since I know it's h comma k, I at least know the h value, and the h value here is a negative 2. So to find k, I plug that back into my original equation. So, okay, we remember that we had y is equal to x squared plus 4x plus 6. So every time I see an x, this is where I will be plugging in that value of a negative 2. So I'm just going to plug this into my calculator. So negative 2 squared plus 4 times my negative 2 plus 6. And I get back a positive 2 as my final answer. So this is actually my k value, is positive 2. So now I have my vertex at negative 2, positive 2. So I'm going to graph that vertex at negative 2, 2. That's my ordered pair. Now for part B, it says to find the x and the y intercepts. So hopefully this is sounding very, very familiar. So to find y-intercept, you let your x value equal to 0. So, okay, we have from my original equation that y is equal to x squared plus 4x plus 6. Where that x value, I'm going to be plugging in a 0. So then y is equal to a positive 6. So my y-intercept is 0, 6. Now I want to find my x-intercept. So we are going to let now that my y value equal to 0. So remember, we have that y is equal to x squared plus 4x plus 6. And we can't factor this, so we are going to use our generic form where we have x plus the b divided by 2 squared plus your k value. And don't forget, we already have the vertex. Oops. And let's actually make this my h value. There we go. So the vertex, remember, was h comma k, and the vertex that we found was negative 2, 2. So I'm going to have this as x plus 2 squared plus 2. And the y value that I'm plugging in is 0. So now from here, I'm going to subtract 2 on both sides. So I can get a negative 2 is equal to x plus 2 squared. And I'm going to square root both sides to get rid of the square. So I have plus or minus the square root of negative 2 is equal to x plus 2. And again, I have a square root with a negative on the inside. So that tells me that there's no real x-intercepts. So the x-intercepts do not exist again, okay? So let's see if we can graph this. So we have the vertex, and we have the y-intercept at 0, 6. So more or less, this is what my graph is going to look like. And so what you can use to kind of help you is the axis of symmetry. So notice how from the vertex to 6, it's 1, 2 over. So going 2 over, I know my other dot is going to be up in here. have a pretty good idea of what my graph is going to look like. Okay? And again, the reason I knew to make that other dot or that other point was because it was 2 over in this direction, and since the vertex is a symmetric along the vertex, then I can go 2 over as well, and it's going to have the same height as that other pair. Okay? And that is it for section 10.4. So if you guys have any questions, please feel free to email me. Thank you.